Good morning. Today we will go back through Fraction Busters, and this is something that we did right before spring break. So hopefully you remember this. If not, that's fine. We're going to go through everything together. And if this is your first time seeing this, then you want to make sure you take some good notes. So why are we doing this? We're doing this so that we can go back and learn again what we learned before spring break. And why is because you're going to need it next year. We will start with a warm-up. Do you remember the whole idea of cross multiplication and division? I hope so. Let's do this problem together. If we were to cross multiply, we would have 4 times 14. Pause and figure out what that is. That is going to be 56x, because the x comes along for the ride. And then 3 times 21. Pause and do that math. That is 63. What we want to do next is we divide by that coefficient of x. Remember that coefficient of x is the number that is right in front. So when we do that division, we make a fraction, 56 and 56. And of course, this is going to be a horrible number, but that's not really the point. So x would equal 1.1, 2, and 5. So hopefully this is a good reminder of cross multiplication and division. Moving on to some former knowledge. If we have a decimal, 0.26, excuse me, and we want to solve for x, it's the exact same understanding that we just did, which is you take the coefficient of x, which is 0.26, and you divide that by making it a fraction on both sides. So 0.26 and then 0.26. And hopefully you remember that when we divide by a decimal, we end up with a number that's bigger. Do you remember when we did that? We got 600. So hopefully these two problems are familiar to you. So moving on to today's learning, Fraction Busters. This method is something that you can use when you have fractions in an equation. You would want to eliminate those fractions and then go ahead and do the solving. You can take a second and read what our learning target is. I can solve an equation with fractions for an unknown quantity. Take a second, just read this page. Okay, so to start this off, hopefully you notice that all three of our fractions have exactly the same denominator. So what does that mean? Since they all have the same denominator, if we were to take every fraction and multiply it by 3, just like this, we would be eliminating all of the denominators. And what would we end up with? 2x plus 4 is equal to 10. Now, do you remember your rules of algebra? You want to remove the 4 on each side. Here is that intentional 0. We have 2x is equal to 6. You divide by 2, and x is equal to 3. We're not done because we want to make sure we check. So we would put in wherever there is a 3, or wherever there is an x, we would put in a 3. And we would do that all the way across and continue on with our multiplication. So we have 6 over 3 plus 4 over 3 equals 10 over 3. And we do have 10 over 3 equals 10 over 3. So we know that our answer is correct. So what about for this problem? We have two fractions that have the same denominator, but we have that x. So here is where we do this whole idea of fraction busters. So the first thing that we want to do is we want to put all of our terms, that's everything that's separated by plus, minus, and equals, into parentheses. The next thing that we want to do is we want to take all of these denominators and we want to make sure that those are going to be our busters. Before we do that, hopefully you remember, we have to take our whole number and make it a fraction by putting it over top of 1. So our fraction busters are going to be just 2. So we're going to put a 2 up on the top, just like we did in that last problem. And we're going to ask ourselves, is there anything that we can bust here in this first fraction? And there isn't. But when we're looking at the second fraction, the 2's go away. And the same thing happens in this third fraction. So what do we have left? We have 2 in the busters, and what's left in the numerator is x, plus all we have left here is a 1, and all we have left here is a 3. So let's get rid of those parentheses by multiplication. 2x plus 1 is equal to 3. Now we are just solving an equation. So minus 1 on each side. That's the intentional 0. 2x is equal to 2, divide by 2, and we get x is equal to 1. We have to check our answer. So we're going to have 1 plus 1/2 is going to equal 3/2. So there's a lot of ways that you can take care of this. One thing I would think about is I know that 1/2 is 0.5. So 1 plus 0.5, and I know that 3/2 is 1.5. So I could do that mental math, and that makes it okay. I have 1.5 is equal to 1.5, and that does check. So our answer, x is equal to 1, is 100% correct. Okay, so moving on, this one is a little bit more complicated. So the first thing that we're going to do is we're going to put our parentheses around every single term. We have 3 of them. And immediately we want to go ahead and we want to put our 5 over the 1. All right. Then we ask ourselves, what are the busters? The busters are each of the unique denominators. Well, 5 and 10 are those nice unique denominators. So we're going to put them up at the top. So 10 times 5 and 10 times 5 and then 10 times 5. Let's go ahead and bust the 10s and then we'll bust the 5s, and we can't bust anything in that third term. So let's go ahead and do the rest of our math. What do we have left as the busters? 5. And what do we have left in our parentheses? 3x in the numerator. Plus, we have 10 as a buster, and then x is our numerator. We're going to multiply those 2 busters that are left to be 50, and 5 is what's left in the top. So now we're just going to go ahead and clear those parentheses by multiplication. 15x plus 10x is equal to 250. We're going to add the 15 and the 10 to get us 25x is going to be equal to 250. We divide by that coefficient of x, and we get x is equal to 10, which feels like a very nice number, but let's go ahead and check to make sure that we did it correct. So here's our check. We're going to have 3 times 10 over 10 plus 10 over 5 is equal to 5. 30 over 10 plus 10 over 5 is 2. 30 over 10 is 3, so 3 plus 2 equals 5. 5 equals 5. So well done. Okay, I'm going to do this again, but what I would ask you to do this time is to pause the video and see how much of this you can do on your own, and then come back to me. So welcome back. So the first thing that you want to do is put your terms in parentheses. There's nothing we have to worry about putting over 1. The next thing we're going to want to do is to put your busters up on the top. Our busters are 8 and 5. You don't have to double the 8 because it's each unique buster. So we're going to have 8 times 5 up here and 8 times 5 over here. And the last one is going to be 8 times 5 also. So we're going to go ahead and bust the 8s, bust the 5s, and bust the 8s. And let's see what we have left. We have a buster of 5 and a numerator of x is equal to a buster of 8 and a numerator of x plus a buster of 5 and a numerator of 9. So we have 5x, once we clear, equals 8x plus 45. We're going to subtract the 8x because that's our intentional 0. We have negative 3x is going to equal 45. We want to divide by the negative 3x, and x is going to be 15. Negative 15. All right. So let's go ahead and check that. Check that. We're going to have negative 15 over 8 is going to be equal to negative 15 over 5 plus 9 over 8. And this is yucky, right? So what I'm going to do is some fancy math, and let's see if you can keep up with that. I'm going to go after this number right here, and I'm going to think about it as kind of a fraction. I'm going to subtract 9/8 and subtract 9/8. So what I have left is negative 15 plus 9. So negative 15 plus a negative 9 is going to be equal to a negative 24 over 8. And that's going to equal negative 15 over 5. And that is negative 3 equals negative 3. So yay, it does work. So again, I would encourage you to give this one a try and then come back and see how you do. So the first thing we want to do is put our terms in parentheses, and you can see we do this time have to add a 1 underneath the 6. Next, we are going to go ahead and put our 2 times 5 on the top, 2 times 5 on the top, and 2 times 5 on the top. There's the train. We're going to go ahead and do some busting. So we have 5 and then x plus 2 and then an x, and that's going to equal 10 times 6. Okay, I think the train has gone by. So we have 5x plus 2x is equal to 60. We have 7x is equal to 60, and we're going to do some division here. And x is going to equal a very yucky decimal. So what I'm going to ask you to do is round to the second decimal, so 8.57. So now when you put 8.57 into the equation and check it, you might end up with a teeny bit of a difference. But that's why I wanted you to do this. So if we check this, and we have 8.57 divided by 2 plus 8.57 divided by 5 equals 6. So what I want you to do is 8.57 divided by 2. 8.57 divided by 2. And that's going to give you 4.285 plus, and then 8.57 divided by 5. And that's going to give you 1.714. And then if you add those two numbers together, I'm doing it right now on my calculator, you get 5.999 equals 6. And you can round that to be 6 equals 6. So the point of doing this problem is to let you know that you have this power in eliminating some of these decimals and just kind of rounding and assuming. So hopefully this made sense to you. At this point, I'd like you to open up your weekly R&P and work on problem number 70, which is 4 fraction busters. You do not need to do all of them, but give them a try.